You ever find yourself just scrolling through your phone and bam, the perfect video pops up? It almost feels like it's reading your mind, right? Well, it's not exactly magic, but it is incredibly powerful. Today, we're going to pull back the curtain and take a look at the engine that runs it all. We're breaking down how AI actually works.
I mean, it's the question we all ask, right? How does Instagram or YouTube just know? How does it serve up that perfect video at the exact right moment? Well, that uncanny ability to predict our next move, it's not a lucky guess, not at all. It's a calculated decision, and today, we're going to break down that calculation.
All right, so for this explainer, we're basically going on a journey. We're going to start with that magic you see on your screen, and then we're going to peel back the layers one by one until we get right down to the core mathematical ideas that make it all possible. And trust me, by the end of this, you'll see exactly how all these pieces fit together to build the smart systems we use every single day.
Okay, so let's get right into it. Every single time you open an app, you're interacting with algorithms. You can think of them as these invisible engines that are constantly working behind the scenes. They're the ones deciding what you see, from your Instagram feed to your YouTube recommendations, and they're what make your digital world feel so uniquely yours.
But here's the thing, it's really not magic. At its core, an algorithm is just a recipe. Seriously, it takes all these ingredients, your likes, your comments, how long you watch a video, and it follows a very specific set of mathematical rules to cook up the next thing it thinks you're going to love.
Now, you've probably heard this idea floating around, that you don't really need to be a math person to get into coding. And look, in some cases that's true, but it really depends on what kind of code you're trying to write.
Yeah, for sure. If you're building a basic website or a simple app, you can probably get by with just some solid logic. But when we start talking about artificial intelligence and machine learning, the systems that have to learn and adapt and make predictions all on their own, well, then math isn't just helpful, it's the absolute foundation. It's everything.
So, what kind of math are we actually talking about? Well, it really just boils down to three essential pillars. These are the big ones, the core concepts that programmers are using to build all those smart algorithms that power the platforms we love. Let's break them down.
All right, so our first pillar is all about translation. I mean, think about it. How do you take our messy, complicated human world, our friendships, what we like, what we do, and turn it all into a language that a computer can actually understand and work with? The very first step, the absolute bedrock, is to turn everything into numbers. Everything. Every like, every share, every connection. Even you, as a user, get converted into a set of numbers. It's the only way a machine can even begin to process all this stuff and start finding patterns in our behavior. Okay, so the most basic unit here is something called a vector. And you can just think of it like a digital fingerprint. It's just a list of numbers that represents one single thing, like you or a video you watched. And what's cool is that in this digital space, things that are similar, like, say, two cat videos, will have vectors that are really close to each other. That distance between them, that's literally how the AI measures similarity. Okay, but now let's zoom out. What happens when you have millions of users and millions of posts? Well, all those individual vectors get organized into this massive grid called a matrix. You can see it right here. It's basically the ultimate spreadsheet, just organizing everything perfectly. And this structure, this matrix, is the absolute key that unlocks the AI's ability to do these huge calculations across billions of data points, all at the same time. Okay, so the data is all neat and organized in its giant spreadsheet. But how does an AI actually use that to predict what you're going to want to see next? Well, that brings us right to our second pillar, the power of probability. Probability is really just about making educated guesses. The algorithm looks at your history, all the stuff you've liked, watched, and shared, and it uses that to calculate the odds, the chance that you'll engage with something new. And this isn't some kind of mysterious, unknowable force. It's not about what the AI thinks you'll like. It really just comes down to a simple percentage, a calculated chance that's based entirely on the patterns it has already seen in your past behavior.
And honestly, this is what demystifies the whole thing. That incredibly complex prediction engine, it's just running simple calculations like this one, over and over and over again, just at a massive, massive scale. So in a very real way, your own past actions become the data that predicts your future.
Okay, so we've got an AI that can organize data using linear algebra and make predictions using probability. But what about relationships? How does it understand that incredibly complex web of connections between people? For that, we need our third and final pillar.
And this is where something called graph theory comes into play. It's a whole field of math that is just perfect for mapping out networks. So in the social media world, every user is a node. You can just think of it as a dot. And the connections between them, friendships, follows, interactions, those are the edges, the lines that connect all the dots.
And this social graph, this map of all the dots and lines, this is the secret sauce. It lets a platform see not just who you're connected to, but who your friends are connected to. It can find all those hidden little groups and communities, which is precisely why it's so freaking good at suggesting people you might actually know in real life. All right, so we have our 3 pillars. We've got linear algebra to organize all the data, we have probability to predict what we'll do, and we have graph theory to map out all our networks. Now let's put it all together and see how the learning part of machine learning actually works. It all comes together in what's basically a continuous feedback loop. Check this out. First, it organizes new data with linear algebra. Then, it uses probability to make a prediction. It shows you a new video. But it also uses graph theory to check if your friends like that same video. Then comes the most important part. It just sits back and watches what you do. Your reaction, whether you like it, share it, or just scroll right on by, that becomes new data. And that new data feeds right back to the start of the loop, making the next prediction just a tiny bit smarter. This cycle, happening billions of times every second, that's the essence of machine learning.
And what's really interesting is that each platform uses the same basic toolkit for its own specific goals. So Instagram might use a weighted average, basically saying a comment is worth more than a like, to figure out an engagement score. YouTube? It uses a statistical trick called regression to predict which video will keep you glued to the screen the longest. And Facebook, of course, leans heavily on graph theory to power those friend suggestions. See, it's the same toolkit, just tweaked for different results.
So, if there's one key thing to remember from all this, it's this. What feels like magic when you're using your phone, it's really just the result of applying these basic math concepts at an absolutely mind-boggling scale. It's not a thinking machine. At the end of the day, it's just a very, very smart calculator.
And this all brings us to a final and pretty important question. We've just seen how these platforms are built on equations that rank, recommend, and connect us. So that leaves us with something to think about. If our digital world is built on math, who gets to write the equations that shape our experience? And what values are they building right into the code that so quietly shapes our digital lives?